Okay. On this next one, it says which statement is true. There's a couple questions about cosine, a couple questions about sine. And it has to do with whether they're even or odd. So remember that even means that if I plug in the negative value for x, the opposite value for x, that I will still get the same value as the positive value for x. And that means that it is symmetrical about the y-axis. Okay? So that's that one. Now, odd means that if I plug in the negative or opposite value for x into the function, then I will get the opposite y value. And that means that it is symmetrical about the origin. It's like a rotation, 180 degrees. Okay. So before I look at my options, cosine is even. And I'll show you why. First and foremost, if I draw a line down the y-axis, the left-hand side is identical to the right-hand side. It's a mirror image. It's symmetrical. So this one is even because it's symmetrical about y. About the y-axis. But more importantly, whatever this value is, so if I go over 1, 2, 3, 4 clicks, this is actually negative 2 pi. But if I go to the right 1, 2, 3, 4 clicks, this is positive 2 pi. So this is my x value here. This is my x value here, but notice that they have the same value. This is y equals f of negative x, but that is the same as the y value over here, which is equal to f of positive x. So cosine is even always. Okay. Now sine, on the other hand, this is odd. Well, why is it odd? Because if I take this portion and I rotate it 180 degrees, this thing will flip and land right on top of this line. Okay? The other thing is this. If I go 1, 2, 3, well, I'm going to go 3 clicks for sine. This value here, 3 clicks for sine would be, what is that, 3 pi over 2? So this is negative 3 pi over 2 for my x value. And then if I go 1, 2, 3 over here, this is x equals 3 pi over 2. But notice that this is a negative y value. And it's the same y value. And let's put the values in here. So at this particular one, y equals negative 1. But at this particular point, y equals positive 1. So when the x's are opposite, guess what? The y's are opposite too. So if I have a function and I plug in 3, whatever value I have for y, if it's an odd function, when I plug in -3, whatever the value for y was originally, I get the same value but the opposite. For an even function, you have the same y value for 3 or -3. Okay, so now that we understand that, which of these statements is true? Well, the function cosine is odd. No. And this is completely wrong too, right? By the definition of an odd function, this is the wrong definition. This is the definition of an even function. The function of cosine is even because it's symmetrical about the origin. No, that's wrong too. It's symmetrical about the y-axis. The function sine is even. Nope, wrong. It's odd. Hopefully this last one will be the ticket here. The function f of x equals sine of x is odd because f of negative x is equal to negative f of x. And what this is saying is whatever this y value is evaluated at the negative x, this will be the same y value but the opposite. And that is true. That's just a little more formal way of saying it.